And welcome to section 3.2. It'll probably be a little bit shorter than what your last one was, except the little classwork part that we got going on. So basically, you've already done most of section 3.2 with the highlighting that you did. I don't know if you bothered to read what was highlighted or if I explained it to you because it was a while ago since I did it. But we're going to go over them again in a little bit more detail so that you can kind of understand what's going on. We also have to talk about some ways of marking our figures again, because I want to make sure that you're doing it right and that you know what you're reading and that you can mark it yourself if you need to. So, which you should always do, incidentally. So, section 3.2 is all about this very first line. If two lines are parallel and they are cut by a transversal, then, and they give all these different things that are true about that. Okay, so when we're talking about two parallel lines, these are my two parallel lines. I don't even have to name them. I know they are parallel because they have the little symbol that states that they are parallel. Put two little arrows on it. That's the way your book states that they are parallel. Now, small little aside. You know, we've been doing the worksheet thing, right? Well, your worksheet doesn't do the two little lines to show that they are parallel. Instead, your worksheet does something else. Your worksheet will say a squiggly there and a squiggly that looks exactly the same on this one shows that they are parallel. Different books have different ways of coming to it. Generally speaking, most people use the arrows, so when I draw figures, and probably on the test, they're probably going to have the arrows and not the little squigglies. But now you know what the little squigglies really are. Now, if we had two sets of parallel lines, then we would have to have two different kinds of arrows. So basically, our first set would have one arrow on it, and if there was another set, we'd have two arrows on each of those parallel lines to show that they were parallel to the one that had the two arrows on it. These do not mean congruent. They have nothing to do with congruency. Congruency is a little tick mark. Remember, a congruent sign just looks like a little slash. These are parallel. Can't call them congruent anywhere. They're lines. It happens like that. They're not segments. They're lines. I know because there are little arrows in the end of them. Okay, so if we have two parallel lines, that's a big if, because you don't always have two parallel lines. The whole last section that we did, there were not two parallel lines in the whole shooting match. Now we are always going to make sure that there are two parallel lines for this particular section. So this particular section is all about giving us the fact that there are two parallel lines and then what that really means. So the first thing it really means is that corresponding angles have to be congruent. So back from the last section, we learned that angle 1 and angle 5 are corresponding. Therefore, angle 1 and angle 5 have to have the same measure because they are also congruent. So, for example, that means that angle 1 is congruent to angle 5 because they have the same measure. Now that we have a reason for all of this, we can start doing proofs with that kind of information. Then what's another, because it looks bad having it way up there instead of down here. So another set of corresponding angles that must be, incidentally, let's just talk about the way things look just for a second. If I look at angle 1, it looks a lot like angle 5. I mean, it just does. It's going to happen with parallel lines that tend to make them look alike. They don't have to make them look alike. They tend to make them look alike, so you can pretty much tell what the corresponding angles are going to be. That would also mean that angle 3 is congruent to angle 7, angle 8 is congruent to angle 4, angle 2 is congruent to angle 6, the one I'm going to write down. Because of corresponding angles. Wrote them in the same color for a reason. Next, it says alternate interior angles have to be congruent. So my alternate interior angles are 4 and 6, and if you will look, 4 and 6 must be congruent anyway, because we just said that 4 and 8 were congruent, and 6 and 8 are vertical. That means 4 and 6 have to be congruent. So alternate interior angles have to be congruent. And the other one was angle 3 and angle 5. Alternate exterior angles have to be congruent. That's what the green says. It might be hard for you to see, but that's what it's saying. So alternate exterior angles are like angle 1 and angle 7. And if you look, angle 1 and angle 3 have to be congruent because they're vertical angles. Angle 3 and angle 7 are corresponding angles. Thus, it is proven that in this particular case, angle 1 is congruent to angle 7, which makes an alternate exterior. And look at that, we're doing proofs in our head now, which the very next step from doing them in your head is to actually write them down. See, it's not nearly as hard as you want it to be. Another set of alternate exterior angles is angle 2 is congruent to angle 8. Interior angles on the same side of the transversal are supplementary. We didn't talk about same side interior or same side exterior in the last video because they're not usually brought together as a pair because they don't normally have anything in common. But now they do have something in common. Same side interior, because we know about the corresponding angles, and 3 has to be the same as 7, and we know 6 and 7 are a linear pair, that would mean that 3 and 6 are going to be supplementary. Can't be a linear pair because they are not adjacent, but they do share the same line, but they are not adjacent with that other line. So since they don't share that same line, they cannot be a linear pair, but they are supplementary angles. So angle 3 and 6 are supplementary. And then, since we're talking about interior angles, angle 4 and angle 5. Incidentally, since we know that, I bet you can figure out that the exterior angles as well are going to be supplementary. As long as they are on the same side, our exterior angles have to be supplementary too, because you could slide them together and make that linear pair if the two lines were the same. They have to have the same slope because they're parallel, so they could be the same if we could slide that together. So the last one kind of is weird wording because I was trying to make it fit with my original statement, and it's not worded that way in the book, but you can deal with it. The last one says that if one of the lines is perpendicular to the transversal, then the other one has to be perpendicular to the transversal. So it actually would look better if I had a different picture. Give me a second. So I'm going to draw one that looks like it is perpendicular. So that one's my transversal. I say that it's perpendicular to this one. I mark that they are congruent, parallel. So since it's perpendicular to this one, you know that this side has to be 90 degrees too. Corresponding angles have to equal 90 degrees, which would make that perpendicular. There are proofs to this. It's all just kind of following the logic of the things that you already know to get there. That's exactly what proofs are. It's following logic of stuff you already know to get to where you want to, or where you're told to go to. So you can see that it's logical that this is true. And now that we have this statement, even though we could build up to this statement, now that we have the actual statement, we can use the statement in our another proof instead of having to build up to it. That's why we have these. I gave you this one, and we could build all of those off of it, but with our vertical angles like I did when I explained it. But now that we know alternate and interior angles, now I can just say alternate interior angles. We know that it's true because it's alternate interior angles. And so when we get to a longer proof that involves alternate interior angles, I can just throw this out instead of having to connect corresponding angles and vertical angles to it. It saves me some time. We're all about saving time. That's why we take shortcuts. Every time we can, we abbreviate stuff. We use symbols. It's all about trying to save you some time. Speaking of saving you some time, I have done it for you, let me tell you. So the classwork for today is actually a worksheet, and I need you to go ahead and get it out. It is also the homework for today. So, well, sort of. So you need to find page 47 worksheet. Xeroxed it, texted it to me, emailed it to your mom. She has it. Do not look at the answers yet. I need to explain some stuff on it. So if you don't mind grabbing that, I saved you time because there's a picture on it, but I have to sit here and draw a picture out. It's going to take me some time, but it won't take you but a second. So go find that worksheet, and when you get back, I'll have it drawn. Told you it wouldn't take but a second. Okay, so this is what it looks like on the top of page 47. Your classwork is going to be to find every angle that is congruent to angle 1 and every angle that is congruent to angle 5, problems 1 and 2. The rest of the page will be your homework. They're not quite as simple as problems 1 and 2, but I did want to go over problems 1 and 2. So if I were you, I would pause the tape now so that you can try problems 1 and 2, and let's see if you actually get all of them. Make sure you pay attention to which ones are transversals and which ones are not transversals, and which lines are parallel and which lines are not. They did what they could to make sure that they showed you pretty easily which ones you can guess and which ones you can't jump to. So I'm going to let you pause the tape and you take care of that, and then when you come back, I'll do some explaining myself. Okay. All right, so this is what happened. They went ahead and they told me that lines A and B were parallel to line C and to line D. So I went ahead and marked them parallel with my angles, with my arrows. So one arrow on each means that they are all parallel to each other. Then they said that lines E and F were parallel to each other. So I went ahead and marked 2 arrows on E and F, so we could tell that those 2 were parallel. Then they said that lines G and lines H were parallel, so that got 3 arrows for this one because they're not parallel to the other lines. So they have to have a separate thing. Okay, so those are my figures marked. Now, they want to know about angle 1. So I start with angle 1, and I look at angle 1, and we have to find a transversal that cuts 2 lines with angle 1. Try to cut out that noise. Okay, so this is angle 1, and if I call E my transversal, then angle 1 is corresponding to angle 13, which means it would be congruent to it. Angle 1, if I call A my transversal, then angle 1 is corresponding to angle 3, which means that they would be congruent. So far we have angle 13, angle 3, but in addition to that, we know that if it's congruent to angle 3, then it's also going to have to be congruent to angle 15, because here 3 and 15 are corresponding. So this is going to get to be a long list. And then if we have angle 15, angle 3, and angle 13, we've got to have the vertical angles to that. So that's angle 20, angle 22, and angle 10. And then, now that we've gotten these intersections, oh, I left out angle 8. Let me throw that one in there real quick. And then, now that we have all of these intersections taken care of, I can come over here to this intersection area. No, I can't. The reason is these were all okay because they were parallel lines. This line is not parallel, so I can't call that a transversal with these over here that are dealing with angle 1. So I can't think about anything that's got these kind of parallel lines on it. I have to stick with intersections that have angle 1 as a possible transversal area. So it's either got to have E as a transversal, or it's going to have A as a transversal. And A can't be a transversal with parallel lines. So with E being our transversal, I have a whole other set down here corresponding from A to C, that could be my 2 lines, or A to D could be my 2 lines that E cuts. So that would mean that 25 was congruent, and if we have 25, that means we also have angle 32, because it's vertical to 25, and corresponding to 1, we have angle 37. And in addition to that, we obviously have angle 44. Now we talked about alternate interior, but this is an interior angle, so we can't count that. But we can talk about alternate exterior angles. Alternate exterior angles to angle 1 would be angle 20 or angle 10, and we've already counted those. So those are the only ones that we have that are congruent to angle 1. Like, that's a small list. I'm just saying, that's why they give you a great big long line there to write that stuff down. So when I go to angle 5, and I'm over here and I'm talking about what's congruent to it, I can't count anything that doesn't have a parallel line shared with angle 5. So I can use A as long as I do that's parallel with this one, and that makes G my transversal. I can't let A be the transversal because there is no other parallel line to G that goes through A. So that means that all of these intersections over here are all out of range. So now we're just talking about angle 5 and these intersections down here that can be counted. So now when I have angle 5, I obviously have angle 12 because it's vertical. I have angle 17 because it's corresponding. Angle 24 because it's alternate exterior. I have angle 29 because it's corresponding. I have angle 36 because it's alternate exterior. I have angle 41 because it's corresponding. Angle 48, alternate exterior. Then we get to come over here, because since we know that it's true over here, I can count angle 36 as a link to my angle 27 and angle 34. And then angle 39 and angle 46. Basically, if you pick this intersection up and sit it down on top of all of these other intersections, it's the one that has the vertical angle and the corresponding angle to it. So that takes care of problem 1 and 2, which were the kind of the challenging ones. The other ones are more difficult just because you got to pay attention to the numbers. So now that you know those, I could have marked all of them congruent, on the figure if I had wanted to, but I didn't want to give you that kind of extra push. So I'll leave that up to you if you're interested in it. If not, struggle through. Won't hurt my feelings at all. But your homework is the rest of page 47. The key to page 47 your mom has. It's a Xerox copy of that too. So yeah, let me know if you have any help, if you need any help, and you'll see me in a couple days. Bye.